Yes, now the next presentation is Heli. So will be about machine learning. So welcome, Heli. I don't know if I speak your name correctly, but the session is with you, and you can continue right now.
Thank you. Can you see my screen?
Yes, working perfectly.
Good, because I'm a little bit confused now because it shows differently to me.
Okay.
Now we are good. Can you still see it?
Yes, amazing.
Good. So hi everybody. It's quite late already. I'm sure you're pretty tired, but I hope you still have the energy to listen what I have to tell. We are going to talk about machine learning and a short introduction. What is machine learning all about? So my name is Heli. The last name is Helskyaho, but nobody can pronounce it. So you actually know me as Heli from Finland. I have graduated from University of Helsinki with a master's degree in computer science and currently working on my doctoral studies. And those are, surprise, surprise, related to machine learning. And that's why I'm so excited about machine learning. I've been working with Oracle for many years, since 1993, and on IT even longer than that. Anything to do with data and databases is very close to my heart. And that's why I find machine learning very interesting, because it's all about data. I'm a CEO for Merkle Finland, a small consulting company in Finland, Oracle ACE Director, and Oracle Groundbreaker Ambassador. To my huge surprise, I have been listed as one of the top 100 influencers on IT sector in Finland 5 years in a row. I'm a public speaker and an author. This is a surprise to everybody since I just said I'm from Finland. Finns are known to be very quiet people, and I just go and speak. That is strange. I have written 2 books. The first one about database designing, and the second one I have co-authored with 4 other people about SQL and PL SQL. Currently working on the 3rd book while I'm working on my doctoral program as well. So quite busy at the moment. And then to the topic. What is machine learning? It is the very important part of artificial intelligence. I would say there is no artificial intelligence without machine learning, because it's the heart or the brain of artificial intelligence. So machine learning teaches computers to learn from experience using the algorithms. Learn from data and make predictions. It's about mathematics, it's about statistics, and it's about your business. More formally said, it's a field of study that gives computers the ability to learn without being explicitly programmed. This is how Arthur Samuel described machine learning in 1959. So machine learning is not a new thing. It's actually older than me, so quite old thing. In other words, we could say that machine learning is a systematic study of algorithms and systems that improve either their knowledge or their performance with experience. The reason we talk about machine learning now is challenges in big data. Big data is not the hippie word anymore. It's kind of gone, but the problem still exists. We have more and more data, the volume. We have different data models and different data formats, the variety. The loading is in progress while we are already trying to do data exploration, the velocity. Not all the data is reliable, veracity. So we are used to have data that we trust, our invoicing system, our orders, and so on. We know it's true. But if we are using data from different sources, we cannot anymore know if it's true, if it's fake news, if it's completely something that has a bug or a virus or whatever. One of the biggest problems is that we actually don't know what we are looking for. We have a lot of data from different sources in different kind of data formats and models, and we don't even know what we are looking for. So that's the value, viability, variability. And also, a very big problem is that actually the business experts are non-technical users, journalists, investors, politicians, big bosses, whatever, people who are not technical. They don't want to use Python or SQL or any language to find information or knowledge from the data. They want to find it much, much easier. So we need to have visualization. And all this must be done efficiently and fast. And the only way to do that is we do it as much as possible by machines. And that might mean that we should be using machine learning. Also, it's much more possible than it was 1959 because we have improved technology. We have GPUs, we have TPUs, all kind of improved technology. And the price for storage solutions has gone down. So we are really able to store the data. We have existing data sets and pre-trained models that we can use to build our models faster and make them learn faster. And we have fantastic research that improves everything every day. I put FB here to remind me that I will say something positive about Facebook, because usually what you read about Facebook is negative, but there is something positive as well. They do a lot of research and they publish their research. So other people can also use whatever they publish. So all kind of research, not just the universities, like my university is doing great research on the area, but also companies are doing research, and some of them even publishing whatever they find out. So we are living in an environment that needs machine learning, and it's finally able to really use it. That's why we all talk about machine learning. So when should I use machine learning? When you have data. It sounds so stupid, but it's a fact. If you don't have data, machine learning will probably fail completely because it is, well, there's an exception I will mention in the end of the presentation where you don't need to have the data, but in general, when you are doing machine learning, you need to have a lot of good quality data. The rules and equations are complex, like for example, image recognition, or they are constantly changing, like fraud detection. So something that you cannot program with if and else, it's more complex than that. It might be a use case for machine learning. But bear in mind that machine learning is not a silver bullet. So if you have a problem with your data or with your business, it's not a silver bullet. It's not the solution for everything. It might be the solution, but we can't guarantee it is the solution. The biggest problems why it might not be the solution are usually the task, the problem that you are trying to solve with machine learning is actually very hard to define. So you can't actually define what you are trying to do, or the data is not enough, it's not good quality, or it actually doesn't have solution for your problem. So usually it's about the data that we struggle when we are trying to use machine learning as a solution. Well, the nature of the data changes and the program must adapt. That's what machine learning is about. My favorite example is predicting shopping trends. So I have two sons, and the younger one is very keen to fashion. So he always knows what's the coolest thing ever. So when I'm traveling, I try to be the cool mom and buy the hoodies that are the latest brand. By the way, all those brands, they are impossible to pronounce if you have noticed. I don't know how to pronounce them. So I always have a note with me that says the name of the brand, and I try to find the shop and buy the hoodie. But the problem is, when I get to this shop, and those hoodies are, by the way, very expensive. I get to the shop, I buy the hoodie, I manage to do all this, and I'm so proud. I'm the coolest mom on the planet. I come home and I give this hoodie to my son, and he's like, Mom, this is so last season. Nobody wears this brand anymore. Now we are all using this and that brand. So if I had machine learning model predicting me the next brand, I might be the coolest mom on planet. Currently, I'm not, unfortunately. So some real life use cases for machine learning. Well, spam filters is a very classical example because it's very hard to program if and else for spams because spams are changing all the times. Or log filters or log alarms. Data analytics, image recognition, speech recognition, medical diagnosis. My favorite thing is medical diagnosis because there's so much you can do with machine learning on that area. Robotics, okay, robots are very nice. They can be so cute and so efficient, and they can do the vacuuming for me so I don't have to vacuum my house. By the way, I still don't have this robot to vacuum the house. It's my dream. And of course, the self-driving cars and so on. So many interesting things could be real life use cases for machine learning. So what is this machine learning then? Well, you can actually say it's three different kind of things: unsupervised learning, supervised learning, and reinforcement learning. Unsupervised learning is finding hidden patterns or intrinsic structures in input data. It could be clustering, it could be anomaly detection, all this kind of things. So we are playing with data we actually don't know so well. Supervised learning trains a model on known input and known output data to predict some future outputs. Typical examples: classification and regression. And then reinforcement learning: the machine or the software agent learns based on the feedback it gets from the environment. Let's talk a little bit more. So I said unsupervised learning is learning from unlabeled input data, so data we don't know. We are trying to find some kind of patterns from that data. We have no target, so we don't know what we are trying to predict. We are just trying to understand the data. This is typically used when we don't have a specific goal, we don't have a target variable, we are not actually sure what information the data contains, or we might want to reduce the features of the data as a pre-processing for supervised learning, called dimensionality reduction. The most used use case for sorting this data is clustering. So putting data into clusters. There's two different kind of clustering techniques: hard clustering and soft clustering. In hard clustering, each data point can only belong to one cluster, while as in soft clustering, it can actually belong to several clusters. So we are trying to find clusters where this data belongs to. Anomaly detection could be unsupervised or supervised learning, depending on the task we are trying to achieve. Anomaly detection is trying to find something unusual from the data, so something that is not normal. Supervised learning is learning from known input and known output data, and the target is known. We are trying to predict those employees who are about to leave our company. We want to find them before they make the decision to leave. Or we want to find the customers who are most likely to buy a certain product. So we have a target and we want to find a way to predict that target for new data. We are training the model using known input and known output, and then we are testing it using another set of known input and known output data. Then we compare how well did the model success with predictions. If it's good enough, we can just deploy it to production. If not, we have to do something. But the key here is that we have to have two sets of known input, known output data for training and for testing. So classification is a classical example of supervised learning. So we are setting classes. So we are trying to find cats and dogs, or we are trying to find horses, cats, and dogs. And when there's a new picture, we have to know if it's a picture of a cat, dog, or a horse. So setting things into classes: yes, no, cat, dog, and so on. This is what classification is all about. Another example of supervised learning is regression. Regression is about numbers. We are trying to predict the next number. What's the temperature next Monday? How much will I get from my house if I sell the house now? How much would I get it? How much would I get from the house? And so on. So predicting numbers. That's what regression is about. So classification is putting things into classes, and regression is predicting a number. Every time I talk about machine learning, somebody asks me, what is deep learning? Because everybody talks about deep learning. Well, I just mentioned the cats and dogs. Is the picture a cat or a dog? That could be a supervised learning problem. That could be also solved using deep learning. So deep learning is different from this regular supervised learning by the fact that actually deep learning is doing feature extraction for us. Feature extraction is a lot of manual work, a lot of understanding the data and trying to understand what are the features, the columns, the attributes, those elements that are important for predicting if it's a cat or a dog, or if it's a car, like in this example. So instead of me doing the feature extraction, the computer will do that for me as well. Well, this sounds like a dream come true. I don't have to do anything. I just let the computer do everything. Well, being honest, it's not, because of course it has its downsides as well. So if we are using deep learning, it demands much more resources than just regular supervised learning. So I need more time, more memory, more computing power, more this, more that, and especially more data, because it needs to do so much more. So deep learning is not a silver bullet either, but for some problems, it might be a perfect solution. So examples for deep learning, like computer vision, face recognition, speech recognition, text processing, a lot of different kind of use cases where we could use deep learning, but it needs a lot of data and a lot of resources. The good thing is that we have already data sets and pre-trained models that we can use for transfer learning and for speeding up the learning process itself. So for those reasons, deep learning is much more able to do things now than it was before. There was a time when deep learning was already doomed as not usable, but now because of all these and GPUs and TPUs, it is possible to use deep learning for many, many use cases. Another thing, especially for image recognition, is a thing called convolutional neural network, CNN or ConvNet. So it starts here with the input. So we have an input of a dog face, a picture of a dog, by the way, very cute dog, isn't it very nice? It goes first to convolutional layers before it goes to neural network. Convolutional layers consist of filters, output and pooling layers, and that the result will be flattened to neural network to process. So all these convolutional layers make it even more possible to use deep learning techniques for image recognition. Another question I often hear is, what is backpropagation or backward propagation? So it is the process for neural network to learn, because I will show again the slide where we have the neural network. So it's about neurons that are connected to each other. So when this neural network is learning, it actually happens with backpropagation, because the first time we set up the network, we are guessing all the hyperparameters. Hyperparameter means a parameter that is defined before we even start the machine learning. Like for clustering, how many clusters shall we have, and so on. So all these kind of definitions need to be done before we start actually building the model, and they are called hyperparameters. So all those hyperparameters that are needed for neural networks are guessed. So we just have a guess what to put here. And we are using backpropagation to adjust those guesses. So we have input X on top of the screen here. Input comes to all the layers we saw in the picture, and we make a prediction. Then using loss function, we see how far are we from the true targets. Remember, we have to have known input and known output to know how we are doing. So we know it should actually be a dog, but for some reason, the model says it's a cat. So the loss function tells us how far we are from the truth, uses loss score to actually use the optimizer we have selected. The optimizer updates the weights. Weight is one of those elements that we have as a hyperparameter. And the backpropagation name comes from the fact that they actually start from the back. So we go to the furthest layer first, the one that is closest to prediction, and we go and update that first. Then we go to the next layer and next layer and next layer and so on. So we go backwards. So using the loss function and optimizer, we are able to actually teach our neural network. So these examples for deep learning, text and voice are actually very good examples because text and voice are quite complex. Natural language processing, automatic speech recognition, text-to-speech transformations, machine translations. By the way, it's actually very good already translating Finnish as well, which shocks me every time because Finnish language is quite unique, very strange language. It can build you resumes or summaries of a text. And all these kind of cool things that actually make people worry that maybe in the future our great-grandchildren don't even have to learn to read anymore, because why to bother? The machine is doing everything for you, giving the resume, reading the text for you, translating it to whatever language and so on. But I hope this concern is nonsense because reading is so much fun. And actually, I wouldn't trust the machine do everything without me understanding what it's doing. So my reading skill is probably needed also in the future. But people do have worries on different kind of things. So I tried it. I tried the talk to transformer, which is one of these tools that will build text based on some words that I give to it. And I put here, Heli Helskyaho will explain machine learning in 25 minutes at Dev Around the Sun event. And it gave me I was hoping it will give me a perfect abstract I can use for my next presentation, but probably I will not, because Heli Helskyaho will explain machine learning in 25 minutes at Dev Around the Sun event to promote the use of HANA to enable complex machine learning for large-scale cloud computing, workshops for developers and companies on cloud computing, and so on and so on and so on. Well, sounds very interesting, but definitely not my abstract. I used another tool, text generation API, and I put the same text here. It gave me a very nice abstract. Heli Helskyaho will explain machine learning in 25 minutes at Dev Around the Sun event and at Microsoft Exchange. I want a machine that can make decisions that you don't have time for. I know how to get an idea, and you can think about a machine like that. Oh my goodness, this is definitely not my abstract, but very fun to read. Translations are also interesting. This is just Google Translate. I put here Finnish and I translate it in English. So in Finnish, I actually wrote here that Heli will give a presentation about deep learning at Apex Connect event. What it says in English here is Heli will give a presentation on in-depth learning at Apex Connect. So it didn't know the word deep learning, and it was thinking it's in-depth learning. So it doesn't know all the words and the nuances in words, but still it's already pretty good in translating things. It used to be very bad. So I'm quite happy about this progress. And also what's different in translating, the translations used to be from one language to another language, from the same language to another language, and so on and so on. Now it's been actually using the same model to translate to different languages. So you don't have to build several models for each of the combinations, but you can use one model that will do the transformations or translations for many different languages. Recommender system is a very classical example where deep learning might be used. So a recommender system produces suggestions or recommendations to assist the users in decision-making process. There's three different kind of recommender systems: collaborative filtering, content-based recommender systems, and hybrid recommender systems. Collaborative filtering recommender system is actually recommending me based on the decisions that other users that have similar taste like me has made. So using the information about other users. Content-based recommender system is recommending based on similarities of items. So if I have liked an item in the past and they have a new item that is very similar to that, it might be recommended to me. Hybrid recommender system is actually using multiple approaches together. Amazon would be a classical example of using recommender systems. Here, Amazon is recommending me books in different languages. I don't speak most of these languages. It's recommending me a book about knitting. I definitely don't do knitting. I used to do when I was young, but my shoulders can't take it. It's too much. After sitting by the computer the whole day, I can't do knitting. So actually, I would not buy any of these books. They are all something that is not interesting to me. And why is that? The reason is that Amazon doesn't know about me. Because whenever I buy something, I usually buy books. We don't have Amazon in Finland, so I don't use it for everyday things, but I buy books. But when I buy a book from Amazon, I don't do it myself. I ask my son to do it because he's so good with all this kind of ordering stuff. So he will order the books for me using his profile. So probably his profile is very interesting with all kind of Oracle books. But I have only used Amazon once when I was, well, actually twice. I have created my author profile in Amazon because my books are sold in Amazon as well. And I have once when I was in Tokyo, I have ordered shampoo and conditioner from Amazon Japan. And that's why it's so confused about me. So what is she really liking and what kind of person is she? Netflix is another example and actually didn't do so well either. They are very good with translations because this is proper Finnish, but the recommendations for me are actually not very useful because most of these that is recommended to me, I have already seen, either on television, on a plane when I've been traveling from one place to another, or I have seen them years ago in Netflix. Well, my husband says it's because I fall asleep when I watch something from Netflix. So they know that. And that's why they recommend me to watch it again because I didn't see actually the whole show. I just saw the beginning and the end. But I doubt they are so smart. So I just think it's because they still don't have enough information about me. So they are trying to guess what to recommend to me. Well, these are quite interesting. I might watch these, but I have already seen them. So what's the point? So recommending is not easy. Another possible use case for deep learning would be visual recognition problems like computer vision, image classification, object recognition, object detection, image captioning, action classification, object image segmentation. Like here, we have a picture and a computer is finding things from this picture. So finding traffic lights, car, truck, person, even a handbag. So all kind of small, tiny little details it can find from the picture. So actually all kind of image recognition things or computer vision things are very interesting. And because I think it's very interesting, me and my husband, we decided that we will try it. This is some years ago already, we tried. So we have a house alarm system that is built using a Python. And we wanted to try some face recognition. So we have Raspberry Pis. I put the pen here so you can see how small everything is. So this is the old Raspberry Pi because this is quite old system already. And we had a camera and we decided we will build a system that will recognize if somebody is at the door and will alarm us there's somebody at the door. Then we were thinking, why not ask the system immediately say there's 2 people at the door or there's 3 people at the door. And of course, this will continue. Then we wanted to tell us who's at the door and so on and so on. But we didn't go that far at this point yet. So we found this wonderful web page, Pi Image Search. If you are interested about anything to do with visual recognition or image recognition or anything to do with images, go to this web page because it's amazing. So we kind of copy pasted the code, edited tiny little bit. It was already pre-trained and everything, so we just started using it. The first test, we are sitting on the sofa in our living room. My husband is just starting the program. The camera is there by the television and it tells us 2 faces, which is true, there's 2 faces. Very interesting, not much work at all. So I have heard that it changes a lot if you add lights, you remove lights, you turn the face, you just have half the face. What if we change the circumstances and make it more difficult for the computer? What will happen? So I was thinking, I have a book of half of Trump's face. Will it recognize Trump or not? So let's see what happens. So instead of telling 2 faces or 3 faces, as my husband, me, and Trump, it also shows one more, the 4th face in our curtain, probably because of the lights. But a lot of smart people said it's probably a ghost in your house that your computer can recognize, even though you can't see it. So probably we have a ghost there. I don't know. But anyway, this was a very fun experience and experiment, just with copy paste and a little bit of editing of Python code. So this kind of machine learning is not very difficult. So what if data is not available? The computer can create its own data. I have here an example. You can go and see it later. I will just, maybe I will show it very quickly, so how it works, if I can get it working here. So the idea here is that we have a car that should learn how to park. Okay, the idea is to find how to park a car without any kind of knowledge beforehand. So here we go. The car comes in. The red is the place where it should be parking is marked as red. It doesn't even know where to go. It's driving to the wrong direction. This is attempt 2, and so on and so on. So it's trying to learn how to park. It continues and continues and continues. It hits here, it hits there. It doesn't know where to go, and so on and so on. It takes quite many attempts. Every now and then it accidentally manages to park, but most of the times it's hitting something. This is 30,000 times of parking. Sometimes again, 50,000, it kind of finds the parking place, almost there. 310,000 attempts later, it's starting to be confident. So I am sure when you started to learn parking, it didn't take you so many times to learn how to park. It takes quite a long. So we will not see longer. You can check it later if you're interested. So it takes long because it doesn't have any knowledge beforehand. And there's no data available how to park. So it has to create its own data to be able to learn how to park. So what's the job I should be doing and what are the things I should not be doing? The thing it's doing is called reinforcement learning. So there's an agent, the car that we just saw here, that takes an action in the environment. The environment is our parking slot here. It takes an action, and based on the action, it ends to another state in a different position in this parking area, and it gets a reward, negative or positive. How well did it go? And based on these rewards, it learns. Again, this is not a silver bullet because defining the reward function is not easy. So should the reward come every 1 inch, or after it finally parks, or every 5 seconds? And should it be -1 and +1, or -1 and +10? Or what kind of reward should it be so it would learn to do the correct thing as fast as possible? So reinforcement learning is not that easy either. It is very good with games. AlphaGo 0. It was a very amazing moment when the computer was able to beat the best AlphaGo player, a human player. So that was kind of very interesting news for everybody. But is it good with everything else? So because it needs a lot of try and error, it's learned so slow, much slower than humans. Is it something useful for other things as well? The good thing is that it will learn to be a perfect parker. It will be much better than I can ever teach to park. It will be much better parker. But do I really want to let it park and crash? Or can I build this kind of program that will allow it to learn? It's like a game, what we just saw. So can I build a game for the machine to learn? So that's a good question. What do we actually want from artificial intelligence? We want to have machines that can learn and think like a human, which is not easy because we don't know how we learn and how we think. Deep learning with reasoning, the common sense. So it has a common sense whenever making decisions. The ability to learn background information without attaching it to a particular task. So when learning to park on this parking area, it should be able to park in another parking area, but will it because that parking area has different circumstances? So to be curious and make observations. If it learns that grass is green, it should be able to know green in another context as well. So this color is green, I already know it. So like children, when you're teaching them, this is a dog, this is a dog, this is a lamp, this is a table, this is green, this is yellow. You keep repeating these things to children and they learn. They learn if the table is green and the wall is green, it's the same green. So it's not a different green, it's the same color green. So how do we teach that to computers? All we do is based on predictions. So we predict something because of the knowledge we have we already learned something and we are using that knowledge in our life, the predictions we know. This is one of my favorite videos. So the monkey was predicting that whatever the trainer put in the cup would of course be there when the trainer opens the cup, but it's not there. So the prediction was broken. And so much fun because predictions are predictions. And if they don't happen, it is strange. Jan de Kan has suggested a thing called self-supervised learning to be the next thing. So we would predict any part of the input from any other part, predict the future from the past, future from the recent past, past from the present, top from bottom. So prevent whatever is missing from the data you have and learn that way. So self-supervised learning might be the way to get computers that can learn better, even maybe close to the way that we learn. And the funny thing is that most of the times when we do this kind of research, we learn from ourselves as well. We learn how we learn when we are trying to figure it out for the computer. Maybe it could be self-supervised reinforcement learning, the next step. Who knows? It could be something very interesting. But whatever it is, machine learning is here today. It will be in the future as well. So it's definitely something that you should spend some time with because first of all, it's really interesting. And secondly, it will guarantee your job because it will not go anywhere. Artificial intelligence and machine learning are here and they will stay here in the future as well. But also, not just that, machine learning is very interesting and it has so many interesting areas. It's not just about one thing because machine learning is a team play with different skills put together. So your probably and most likely the skill set you have is needed. Most of the thing we do in machine learning is preparing the data. That's probably something you have already done for years because that's what we do when we play with data. So it's the same thing here. And then everything else on top of that. So it's really, really interesting. And besides, you can help your company by learning something new from the data and help them to make better business decisions based on whatever you learned from the data. So I just suggest you pick your area and start learning because machine learning is so interesting and so full of all kinds of interesting things. I was thinking I speed up a bit because I know you all want to go and have your evening snack and go to bed. So just spoke a little bit faster so we will have some time for the questions as well. I hope you learned something new here. And let's see if we have any questions.
Yeah, I will try to see if I have any question here. I have one, if you don't mind.
Mhm.
It's Rodrigo speaking. What was the coolest project that you saw machine learning working, like in a company or
My
that you?
favorite one is my first project, of course, and that was a factory. So I was in a factory talking about something. Actually, I was talking about virtual machines, which is not related to this topic at all. So I was in the factory and meeting the manager and solving their problems with virtual machine. And suddenly I heard a big bang. I was like, what happened? I said, no, don't care about it. It's just one of the machines. It just went off and was like, is that serious? So, yeah, well, not really. Nobody was hurt. I was like, yeah, but do you need to close your factory now because of that? He said, yes, we have to close it because we need to restart the machine again. And it takes about 1 hour to restart. So I said, you have a factory closed for an hour because of this incident. And he said, yes. And then I said, what's causing that? So why does the machine stop? And he said, we have no idea. Well, I said, how often does it happen? And he said, well, I can't remember, every now and then. I was like, okay. And I said, can I see the factory? It would be very interesting. So we went to the factory and there's a lot of IOE everywhere. There's temperature, there's all kind of machines recording everything that happens in the factory. So they have all the data, what has happened in a factory. So we collected the data and I said, can I keep this data and see if I can find anything from it? And he said, sure, go ahead. We have plenty of data. Just keep it and tell us if there's anything you find from there. And actually, yes, we did find from the data. We found out that when they open one door at the factory room, the temperature goes down a little bit and the machine breaks down because
Wow.
of this temperature change. And
Wow.
it was so amazing.
Yeah.
It was a little bit difficult because it didn't happen exactly the same time because the door was opened and then, let's say, 5 seconds later or 10 seconds later, it happened. So it didn't happen exactly the same time. It would be hell easy to find. It happened kind of first the door and a little bit later the machine. So that was super cool. And they were so excited when we actually found out this. And ever since the door was not open, they locked the door. So don't open the door. And that was the solution. So it
Well,
can be any kind of problem that is solved with machine learning.
very nice. We got two more questions. Can you let us know the learning path from DB admins to machine learn?
The learning path for
Yeah.
DBAs is
What kind of books or
yeah,
yes.
yeah, good question. Well, as I said, the biggest thing is the data, and that's something you already know. You know SQL, you know PL SQL probably. You have a lot of tools you can use for the data itself because the data, first of all, we have to prepare it so that it's good quality. We don't like nulls. Nulls are confusing. We might need to be some normalization or standardization for the data and this kind of things so that it's capable for the algorithm to process. So there's all kind of pre-processing for the data before we even put it further. So number one is preparing the data. So that's probably something that is very easy for somebody who's already working with databases. Well, the second question is what language to use. So how to move on from when you have prepared the data. Because machine learning can be done with, let's say, every language, because most of the languages has libraries for machine learning, especially the basic algorithms that we use for those use cases I explained earlier. So depending what you want to use, if you want to stay with PL SQL, you can do that because Oracle is offering for free Oracle Machine Learning for SQL, which is PL/SQL packages in the database. You can use those to actually to pre-process the data, to build the model, to test the model, to evaluate it, to deploy it. So the whole thing you can do using PL/SQL. Or you can use Python, which has the coolest libraries probably. Well, depending who you ask, somebody might say it's R because R is the one that statisticians are using. So when they invent a new wonderful algorithm, it's first in R and then in Python. So depending who you ask, what is the best for who, but I would say that depending on your background, choose and the company you work, choose the language. Because don't let the language choose you. So not that your friend says that R is the best, I'm going to use R. No, if your company is not using R, your company is using Python, then maybe Python. Or if you already know Python, why not to use it? Or if you already know R or Scala or whatever, you already know that language, maybe you should start with that. Because there's so many other things to learn than a new language. So probably I would go with the language I already know at least a little bit.
Okay, we have one more question. Heli, regarding predictions, how much we can really trust on the that machine will be accurate? Machine learning with AI can be fully trusted?
No, they cannot be trusted because it's all about, well, already mentioned the data. So if the data is crappy, everything that comes out from the machine is crappy. So it starts already with the data. And the second thing is the algorithm and the hyperparameters. If the hyperparameters are wrong, the result is wrong. And there's a lot of discussions now in Twitter about bias. There's this example when there's a face that is transformed to a more visible face and then back to a little bit dimmed face. And it's doing the transformation as a white man. So whatever the original picture is, it's transforming as a white man because of the bias in the data, because it's trained with faces of just middle-aged white men. So that's all it knows. So it's doing all the transformation like that. So the bias in data or the nulls in data, because null means nothing, or anything in the data that is not correct will cause wrong predictions and wrong actions. And all the hyperparameters in the algorithm that are not correct will do the same. And also the fact is that when you have built a perfect model that will predict always correctly, something happens and breaks everything. Maybe you have more noise in the data or you have different kind of data or whatever, and suddenly the perfect model doesn't work anymore. One classical example is a deep learning model that was very good in knowing if it's a dog or a wolf. So if the picture is of a dog or a wolf. You know, it's very difficult even for human eyes to know if it's a dog or a wolf. But this prediction was always correct. It always knew which one it is until one picture came. And instead of saying that it is a dog, it's a dog, it says it's a wolf. And everybody can see it's a dog. So why is it saying it's a wolf? Because what the machine actually learned was the difference between grass and snow, not dog and wolf. So when something is on grass, it's a dog. When something is on snow, it's a wolf. And now we had a dog that was on snow, so it is a wolf. No, it's not a wolf. So we definitely cannot trust the machines to be accurate. In the best, machine learning is a wonderful guess, but it's never the truth. That's why we are needed. So we need to be there to see when things are going wrong. And first of all, that's why we have to evaluate the models very carefully. And secondly, when the model is in production, we have to follow the metrics and see how it's doing. And to be able to do that, we have to have metrics defined. So like accuracy must be 95% or 99 or 87 or whatever percent. And if the accuracy is going lower, we need to do something. At least we need to find out why, what went wrong. So when people say that machines will replace us, I will say definitely not, because we are needed there. They are still machines. And at least not yet, they don't have the knowledge we have, because they don't have this prediction power we have. We are predicting things like something in a cup is still there when we shake it, and if it's not there, it's a surprise. So no, machines and machine learning are not accurate, and they shouldn't be trusted blindly. Definitely not.
We have two more questions. Which path, in your opinion, is good, or it's better, Oracle machine learning or Python with its own libraries?
If you have Oracle background, I would probably start with Oracle machine learning, and there's many options with that. So you can use the autonomous database that has notebooks, and it works on the free tier as well. So you can just start with the free tier autonomous database and start using machine learning there. Or if you have it in your virtual machine, you have your database there, you might want to use SQL Developer that has a data miner add-on that you can just, it's a drag and drop tool where you don't have to program at all. You just drag and drop things and you'll build your model. But if you're already familiar with Python, that's not a bad option either, because Python is already, as you heard in the previous session, CX Oracle is a library to use data in Oracle database and code outside Oracle database. And Oracle is building a thing called OML for Py, which is Oracle Machine Learning for Python. So it will be Python code inside the database. They already have the data science cloud that also has Python available. So Python is a horse I would bet if I want to. Well, they also have R in Oracle database, but Python is something that both Microsoft and Oracle is obviously betting on. So if you want to take another language, I would probably take Python. And you could start now, like you just learned in Bruno's presentation, using CX Oracle and a outside database, and then later on move that code inside Oracle database, and the same code should work there as well. So either of these two, depending on your background and what you want to learn.
Okay, I think we have just one more.
Okay.
Any tips with the best practice for structuring data lake to receive structured data and NoSQL?
I am biased on this question because I am a data vault person. So I believe in a data vault methodology, which has its own rules how to do that. So I'm not sure if you're familiar with how it works. So it has certain kind of structures that should be built, and it has a hash key that will join data to each other, including NoSQL, so and Hadoop and whatever is where you have your data stored. So using the hash keys, which is the primary key for all the data, you are able to actually combine different kind of data to each other. But my number one tip is when you store data, try to understand what you store. Actually, now we are talking about my thesis. So don't save data without understanding what you have, because if you store data and you don't know what you have, you will never use it. So when you are storing the data, you should understand what it is. Is it a recipe for a cake or is it a cat video? Because if you don't know which one it is, it's wasting space in your disk. So number one advice is understand what you are storing. And if you store different kind of data, like in this case, you will have structured data in a relational database and you will have semi-structured data in NoSQL, have some kind of way to understand what parts of them are the same. If you're using Oracle database, that's actually, well, depending what kind of NoSQL you're using. If you're using JSON, JSON has wonderful support in Oracle database. So I would not use NoSQL. I would put it in Oracle database as JSON. But if you're using a different kind of NoSQLs, if you by the way, if you're using Graph, I would also use Oracle database for that because it has very good Graph database as well. If you're using the other NoSQLs, by the way, NoSQL, I hate it. I hate the name NoSQL, and I hate the fact that it's actually an umbrella for so many different solutions. So it's just a weird concept in general. But what how we call is a semi-structured data. So somehow you have a structure for the data, and therefore you know this is related to the same customer. This information is related to the same customer as the information or the data we have in our database, our relational database. So have some kind of way to be able to join that data, to be understanding it's the same customer. So whatever the system is, how you do it. Data Vault has its own ways to do it. That's why I like it. So I don't have to think how to do it.
We have more questions. One is, what do you think about for the future? I mean, for using machine learning with quantum or something like that. Because what is the best language to learn for the future? Because Python and other language came from the previous that we are bits, and just that 0 and 1 is if and else. But for the future, what do you think that can be the next step?
Yeah, that is a good question. But I usually tackle that by saying that language is just a language. So if you know how to program, learning a new language is piece of cake. And I have actually proven that, because when I started doing my PhD, I had a professor who told me on Friday that he doesn't understand how I ever got my master's done without knowing Java. Because when I was doing my master's, everybody was doing Pascal. Java was maybe just invented or something, but nobody was using Java anyway. So he said, how did you get that? Because this has to be done using Java. That was Friday. I was like, who cares? So the whole weekend, actually the Friday evening and the whole weekend, I taught myself Java. I programmed the whole thing that was supposed to be done, and I actually even optimized it. And on Monday, I went to my professor and showed him, here you are, this is the Java program. It's doing everything you said, plus it's optimized. And he said, oh, I knew you can do it. You were just saying you don't know Java, but you know Java. I said, I didn't know on Friday, but I do now. So any language you will learn. But the skill of programming, you have to learn first. So how to do programming. So any language, for me, well, I'm a little bit biased here because for me, Python is kind of familiar and R is a little bit strange. It's like backwards to me. So if I'm okay to do R, but I kind of feel I'm doing everything backwards. And my friend who's from statistics, she loves R. She said it's the best language ever, and Python is crazy. So depending who you are, you feel different languages differently. So very hard to say who will win, but if you hear Oracle and Microsoft, probably Python will do well for the next years. Who knows?
Very nice.
Yeah. I like Python. And I saw the comment about knitting. I do like knitting, being honest, but I stopped knitting when I was about 20 something because sitting the whole day by the computer and then knitting afterwards, it was really bad thing for my back and for my shoulders. So I was having headache every day. So that's why I stopped knitting. So actually Amazon was very, very right trying to recommend me knitting books. I have a lot of interest on the area, but I know I have my limitations.
We got one more question from YouTube channel. I think you already replied with the last question, but anyway, do we need to focus on using algorithms first, and we have to understand algorithm code?
When you start, I would say that you should understand what kind of problem you are solving. So what type of problem you are solving? Is it regression or is it classification? Is it clustering? And then based on that selection, your language has some algorithms available for that type of problems. Then you try all those algorithms and see which of those is the best. At the point, you don't have to understand how they work. You just see which one is the one that suits your need. So depending what your metrics are. So what's important to you? Does it have to be very fast to learn? Does it have to be very accurate? Do you have to understand how it works? So there are different metrics that are important to you. So this algorithm, let's say you have 3 different algorithms available for, let's say, classification. So which one of these 3 is the best? And then you use that. Later on, when you are more familiar with machine learning, then go and find out how the algorithms work. I am so curious. I always want to know how it works. So I really want to know what's the difference between the 2 algorithms, but don't do it in the beginning because there's already so much to learn. So just learn the big picture first. So how to do machine learning, how to get the predictions out, how to understand if the prediction is good or not, and so on and so on. And after that, go to details. But this answer was my answer, and my statistical friend would say, no, it's the opposite. Go to algorithms first and understand how they work because I want to know the details before I do anything else. So again, depending on the person. But I would say no. Don't go to algorithm details in the beginning unless you are a mathematician and you really love algorithms. Then it might be your way.
Okay, perfect. So I would like to thank you for the amazing presentation, Heli, as always.
Thank you.
I saw some of your presentations before, and thank you for joining us today. Thank you for speaking on the LuxOUG. Also, I would extend my thanks to all previous speakers, Tom, Pete, Bruno, and all of our attendees today. Tomorrow we will have more lectures. Tomorrow, okay, I think Pete wants to say something. Let me see here. No? They wanted, no, okay, I'm sorry. And tomorrow we will have a full day of presentation, including Karen Agayev, Nikitas Shenakis, Frank Weber-Faust, and also Rodrigo Jorge. Okay, so see you guys tomorrow, and thank you for coming today to the LuxOUG Virtual Tech Days. Bye-bye.